Welcome everybody to the next installment of the Ask Tom office hours for the Autonomous Health Framework. I'm joined today with Barry Gleeson, who's the architect of the Oracle Database Quality of Service Management. I'd like to advise everybody that this session is being recorded and that everyone except the speakers is muted. But you can ask questions at any time via chat. We also have some questions preloaded, which if there are no chat questions, we'll go through. I would admonish, though, that we will not answer any SR-based support questions. These questions should be more about functionality, use, etc., versus specific support requests. So with that in mind, I would like to open the chat to any questions to start with, but please note that there is the possibility that one of us may say something that is not in the public domain yet, and so please note this safe harbor statement is in place. So given that, anybody on the chat have any questions to start with? All right. Well, then let's maybe warm things up, Barry, by let me just get rid of this. There we go. Let me warm things up by asking you, what was the goal in developing Oracle's Quality of Service Management?
Yes, why did we do this? The goal is basically to help customers deal with the kinds of response time problems that show up when there are load surges. And they seem to be becoming increasingly frequent as applications get more exposed to the internet, where there are large numbers of potential requesters who might converge on a website and cause the amount of load on a particular database instance or collection of instances to go up for some period of time. And the question is, what can you do right at the point where that happens? When things are running normally in production and the load changes unexpectedly. That's the basic goal.
Okay. Sounds like an admirable cause here. So if we're talking about database, basically applications, so what collection of servers and databases can QoS actually manage?
Yeah, so what we'd like to be able to do, what we actually do is to try and rearrange the resources that are available to help deal with the load surge. And that invariably involves some level of trade-off. You need some place to get resources from to help out with the problem. So the scope that we manage is actually a CRS cluster. We will manage all of the servers and databases, or the ones that you want us to, from a particular CRS cluster. That's the scope within which we'll try to make trade-offs to deal with your performance response time problems.
I see. So when you're talking about response time issues, how does QoS manage, define, and measure what response time really means at the database tier?
So what we try to do is we group together requests that are similar in resource consumption and response time, in their resource consumption and response time profiles. So we try and end up with a small collection of what we call performance classes that the database is then asked to measure response times and various other things, resource consumption information for. And those are the things that we try to manage to specific response time objectives. So the response time is measured as from the time a packet arrives at the database with a request in it until the time a responding packet is sent back to the mid-tier or SQL Plus or whoever is making the request. And we collect together those numbers for similar types of requests, and then report the averages of those response times.
So you were mentioning that based on those response times, you wanted QoS could trade off or manage resources. So what type of actions does actually QoS Management recommend to help maintain those response objectives?
So there's a number of different knobs, we call them knobs, that we can turn when there's a problem with response time for one of the performance class, one or more of the performance classes. And they range in scope from inside a specific database to larger scale things across an entire CRS cluster. So starting at the smallest scope, QoS Management will ask the database resource manager to change the level of access that a particular class of requests has to the CPU. So the resource manager has a notion of consumer groups, consumers of resources, and allows us to set a number of shares to each consumer group. Consumer groups with more shares get faster access, more access to CPU than consumer groups with fewer shares. There is a similar concept in the database resource manager with PDBs. So if I've got a CDB with a large number of PDBs in it, we can adjust the number of shares in the resource manager that each PDB gets. And that allows us to speed up one of the PDBs and at the expense of another by giving the first PDB more access to CPU. That will cause the other PDBs to have less access to CPU. If I go up another level to a coarser-grained knob, if I've got a server that has multiple database instances running on it, each one of those instances can be caged by the database resource manager so that its foreground processes only use a limited number of CPUs. And QoS Management can adjust those numbers so that if I've got, let's say I've got 2 database instances on an 8 CPU box, and they're using 4 each, then we might choose to increase one of them to 5 and decrease the other one to 3, thereby giving one collection of performance classes more access to CPU and another collection of performance classes less access. I see that we've got a question in chat, Mark.
No, actually we don't. That's just my advice. That
okay.
They can ask follow-up questions while we're engaging here.
I would like to encourage people to do so. So I've talked about 3 knobs so far. I've talked about consumer group shares, I've talked about PDB shares, and I've talked about CPU counts for database instances. There is a 4th knob as well if you have a policy-managed CRS cluster, where we can actually change the number of machines dedicated to particular classes of work by adjusting the sizes of the server pools that make up the CRS cluster. Mm-hmm. So that's the set that the current set of types of recommendations that we make today.
So if it looks like QoS Management acts as a governor over all of the databases that are running in the cluster.
Yes. Yes.
And so in that sense, it's basically trading off resources. So what happens if there is such a load surge that there's simply insufficient resources to meet all the objectives and to make that trade-off?
Right. So this is actually a core value, a thing that QoS helps with. When the performance classes, the different classes of work are defined, we ask for an additional input from the administrator, and that input tells us something about how business critical each one of the classes, the performance classes are. You can say it's the highest, high, medium, low, or lowest. And what that tells us is when there's too much work to do, when the available physical resources, CPU, et cetera, is unable to cope with the entire load, what should we let go of first? What should we give up on first? So we try and give up on the lowest ranked performance classes first to maintain the response time objectives that you've set for the higher ranked performance classes. And we do that continuously. So when the load is low, everyone's going to be green. Everyone's going to be meeting their objective. As the load increases, if we get problems, our goal is to keep the highest ranked things green and allow, if necessary, some of the lower ranked things to turn red, to stop meeting their objectives. That's the basic plot here.
I see. So when we have a response time problem, are all the actions guaranteed to make things better, or are there situations where perhaps some of the actions just are not able to help out?
Yeah, there's a couple of different things that can happen, limiting cases, if you like. The knobs have limits to how far they can act. So, for example, if I have a pair of database instances running on a machine, let's say it's an 8 CPU box, just to pick a number at random. Earlier I talked about having it split between 4 CPUs each. If the first database instance is really having trouble and is running higher ranked work than the second database instance, then we will, in steps, take the first database instance to 5 CPUs, then to 6 CPUs, and then to 7 CPUs. We will not take the 8th CPU. We will not, as we increase the CPUs being used by the more important database instance, we'll be decreasing the number of CPUs that are the less important database is allowed to use, but we won't shut it down. So we'll get to the point where that knob is at its limit. It can't be taken any further. There are similar limits for all of the other knobs. And if we get to the point where we can see that there's a problem with a particular performance class, but there's no action that we're able to take to improve the situation, we'll report that and wait for the load to subside. We do something similar if the problem is one that, for example, if we're having substantial, unexpectedly high I/O times, we don't have any actions that can actually change how long it takes to do an I/O. All of the available actions at the moment are focused on access to the CPU. So there's a couple of situations where we can get essentially to the end of the road in terms of what actions are possible, given the available physical resources and the available knobs. And that's quite clearly reported, but at that point, there are no recommendations for further action.
So what you're basically saying is QoS Management will actually not shut down workloads from the standpoint of either the service or the database instance should conditions become severe, and it will just minimize their use of resources.
Exactly. Yes.
Well, we have those situations. You mentioned about the ability to rank workload, which looks like a great feature, especially in a consolidated environment. But there's a very real use case of my rankings can change based on time of day and day of week, end of quarter. Does QoS, do I have to manually go in and change the rankings each time, or does QoS have a facility to accommodate that?
We have a facility to accommodate that. The basic idea is that at different times of the week, like weekends and weekdays, you can choose from a collection of policies. So you might have a weekday policy or a weekend policy or an after-hours policy or a end-of-quarter policy. And what changes when you switch policies from one to another is the ranking of the different workloads, which is the most important for this period of time, and also possibly the response time goals, the response time objectives for each of the performance classes. So during the day, you might want to have really snappy response time for things that support browsing for products or purchasing things or whatever. But you might be willing to let go of that in the evening so that reports can be run and have reasonable completion times on those. So as an administrator of QoS, you can set up a collection of policies, and then it's straightforward to switch from one to the next as you want as time goes by. You don't need to change the details. You can select the policy as a whole.
You mentioned about changing ranking and performance objectives. Do these policies govern startup, shutdown, any actual actions of my databases?
We do. The database today does actually take notice of any ranking information that you've given to QoS. That information is passed along to the databases and to Clusterware, and is used, for example, in sequencing startups and making sure that the databases that are running the most important work get first access to real-time scheduling slots on the box. There's a variety of things like that we do, where the ranking gets passed on to other facilities.
Okay, well, this policy feature looks like a great advantage to making use of this. But do I have to switch the policies manually, or is there some facility that I can do this on, basically a scheduler calendar?
There's a scheduler in EM that can be used to do this. You can do it manually from EM, from the QoS pages. There's a button to push to choose a different policy, or you can set up a schedule. There's a command line tool that can be run out of cron. There's a variety of ways to get it done on a schedule.
So I have full flexibility with regards to doing this on either an event basis or calendar basis.
Exactly.
So you mentioned EM. So what type of user interfaces does QoS Management support?
It's primarily driven from EM. There's some minor things that are like switching policies that are done with a command line, but the primary interface is EM.
Can you explain why that a lot of Clusterware functionality has a selection of different interfaces? Can you go into a little bit of detail why?
Sure.
Really only EM?
I mean, the key issue and the reason that the primary interface is a GUI is that there's a lot of graphical information that you can see. That there's a dashboard that shows status and history in a graphical form. There's drill downs where you can go and look at recent history of response times and resource consumption patterns. This kind of view, the dashboard view, is not easy to reproduce with a command line utility at all. The goal has been to give you an overview of how your entire cluster, all of the databases in your cluster, are running, and how that is reflected in response times across a collection of performance classes. In presenting that, it really needs a graphical presentation.
I see. So do I need, so is there specific plugins for Enterprise Manager? Do I need packs to make use of this functionality?
No.
What can you describe what functionality is actually in EM?
So if you've got a clusterware installation and you're using EM to manage it, there's a section of the cluster target. You can navigate from the cluster target to a collection of, to a dashboard for QoS and to some wizards that let you do a variety of things. I talked a little earlier about the performance classes. There's a wizard that helps you define performance classes, their ranking, and their response time goals, and lets you define the various policies that we talked about a little earlier. There's a dashboard that lets you see what's going on in the cluster as a whole, and just under that there is a panel that gives you any current recommendation for actions that QoS might be recommending at this point in time. You can, through this interface, also, when you establish the policies, you can tell QoS that it has the authority to take various actions autonomously. You can choose whether you want us to take the actions immediately when we see a problem, or whether you want us simply to display a recommendation in the dashboard. And when we do that, there's an implement button that you can push. Also from there, there's places that you can go to see graphs of recent historical behavior of the system. I think I covered all of the bases.
Okay, all right. Well, that sounds quite extensive. So you talked about QoS managing these resources. Is that the only benefit that DBA or admin can reap from QoS management?
I focused on the management aspect here because that was our original goal, was what to do in the case of a load surge and to make recommendations. But there's a collection of, it takes a while typically for people to learn enough about how their system is behaving to go through all of the processes involved in creating a policy set, a collection of policies. So we've provided, if you like, an on-ramp. There are modes of QoS management that help you learn about the behavior of your system. The first one is called measure-only mode. And one of the challenges is in getting QoS up and running is to make sure that you've defined your performance classes appropriately, that the response times that you're measuring are ones that are meaningful from the point of view of the customers of the database layer, so the mid-tier or whatever. In measure-only mode, actually the very first step is to create what we call a default policy set. And this is done automatically. And when you use the default policy set, what you get is a performance class for each database service that is defined in the cluster. And all of the performance classes that are defined this way are marked that you want to measure them, see what they're doing. And we recommend that you run this way for a couple of weeks just to get a feel for what's going on in your cluster. You may learn from that the definitions of performance classes that were generated from the services are a bit coarse. They may quite often, a mid-tier application will send requests with quite different response time characteristics to the same service. And so there are facilities, which we'll detail a little later perhaps, that let you define performance classes a little more finely. Or you may discover that there are services that have really similar characteristics, and you may want to group them together so that there aren't too many different response time goals to think about at the same time. So that's the first. In measure-only mode, you see response times, and you also see resource consumption profiles. You can see what fraction of the response time comes from actually using the CPU and what fraction comes from needing the CPU and not being able to get it, to waiting. So there are weights of various types. And we group together the wait events from the databases into much larger buckets. We have a bucket for I/O, we have a bucket for RAC global cache operations, we have a bucket for the CPU, and we have a bucket for everything else. And in measure-only mode, you will see how much of the response time is disappearing into each one of those buckets, which can give you some high-level insight that is not so easy to get sometimes by looking at AWR reports and things like that. So, and you can see it across all of the databases in your cluster simultaneously, which can be quite helpful. The next sort of step down the path towards getting QoS able to manage is to set response time goals. And when you're in measure-only mode, you can see the response times, you can see graphs of how response time has changed in the recent past. And from that, you'll get an idea of what would be a reasonable response time objective for each of the performance classes. Now, you may want to run with those response time objectives set for some amount of time so that you can see how often the response time goals are not met. So this is a level of functionality we call monitor mode. You set a response time goal for performance classes that you are interested in, and when the response time goals are not met, EM alerts are generated to tell you that there's a problem. At this level, we don't actually make recommendations about what to do. We just tell you when the performance goals are met and when they're not. And you can use the regular EM alerting machinery to let people know that there's a problem. Those are the levels. And then finally, you can say, okay, I want QoS to actually make recommendations about what I could do to help particular performance classes. And you can enable the recommendation level individually on each performance class. You can decide which ones you want to get recommendations for and which ones you just want to watch. And then there is a final level, if you like, which is the level at which you say to QoS Management, okay, if you see a problem of that, if you make a recommendation to turn a particular knob, please just go ahead and do it right away. Don't wait for me to come back and press the implement button to say that you want the change made. We wanted to be sensitive to some of the changes can be disruptive. I mean, they actually involve moving resources around, reducing the number of CPUs that are available to a database instance, or even starting and stopping database instances in the case of changing server pool sizes. And so there's a granularity of control over what you as the administrator would give us as the QoS manager authority to do autonomously.
I see. So if I'm just simply monitoring and I get performance violations of my objectives, does QoS give me any insight into the nature of why I'm getting that problem?
Yes, you get information about which type of, you get information about which database instances are involved in the problem, and you get information about which resources those instances are using that are contributing to the most to the response time problem that you've got.
So even though I'm not having QoS manage, I do get information about where my bottleneck might be.
Yes. At this level, we're pointing to the resource that we believe is causing the performance objective not to be met.
Well, that sounds quite useful. So you mentioned about these various modes of operation. What is the best practice on making use of these modes in anger, so to speak? The sequence I described a little earlier is what we recommend, that you start with measure-only mode using the default policy set. And you need to go through the complete cycle of likely load variation, the sort of normal variation you see in load. And that's got to be at least a week. Perhaps 2 or 3 weeks would be more appropriate to be sure that you're measuring the right things and seeing the right response time, seeing the normal response time variation. From there, you can enable the monitor mode and the management mode for individual performance classes as you see fit, I think. Is there any guideline as to what my performance, how tight a performance objective I should have relative to my SLAs or things of that nature?
Yeah, that's a really good question. The performance objectives that you give to QoS are the response time values at which QoS tries to act. Okay, it's actually, you can think of it as an action threshold. Okay, now you don't want to act until there has been, until the performance is degrading somewhat. You don't want to cause actions to happen when performance degrades by 10%. You probably want to take actions when the response time is double the total resource use times. I mean, if I'm spending 10 milliseconds of CPU time on each request, a good point to act might be when the total response time is 15 or 20 milliseconds. So the wait, the additional time that the response is sitting waiting to use the resource, like the CPU, is about equal to the amount of time that it spends using the resource. Now, there's another side to it as well, which is that the SLA that you probably want to set up with your end users you're going to want that to be a number larger than the action point, the point that we set for QoS. So just to pick some numbers out of a hat, if the CPU use is 10 milliseconds, the performance objective that we give to QoS might be 20, and that would be reasonable for an SLA to the end user of 30, 40, or 50 milliseconds. When QoS takes an action, when the response time hits 20 and QoS takes an action, it takes a while for that action to take effect, usually a couple of minutes, sometimes as long as 5 minutes, sometimes a bit longer than that, depending how large the action is. And the load may be ramping up during that time or may just have spiked and stuck there. So you want QoS to act before you get near the service level agreement that you have with your end customer, but not have it be twitching every time the response time changes by a little bit. And so there's some judgment required in the process here.
I see. Well, that makes sense, and sounds like good advice here. We've been talking sort of about the database as sort of this black box relative to QoS management. Mm-hmm. Are there any specific database deployments that I'm required to use to make use of QoS management, or can I use any Oracle database? Can you go into that detail?
It needs to be a RAC database or a RAC 1 node database running in clusterware. But other than that, there really are no restrictions. Every database since 11.204, I think, has had the appropriate machinery inside the database that QoS uses to do the management.
So I had heard that one time that I needed to have a policy managed QoS management database when they introduced both modes of deployment.
Right.
Is that still the case?
No, that hasn't been the case for some time. We started out only managing databases that were policy managed. And the goal there was to have the ability to adjust the number of servers that are applied to a particular class of work. But we extended it to work in all clusterware configurations some time ago.
I see. So we have a question from Pyong that he's asking whether or not for QoS we are evaluating SQL that is already running. So I'm assuming he's saying that QoS is looking at workload that's already running. Is there a way to prevent new SQL from being fired if the system is already overloaded?
No, there is no way to reject new requests at this time. That's an interesting suggestion, something that we've thought about. The challenge with rejecting new requests is that causes an error to the application that's making the request. And so by introducing a new kind of error, you can create problems further out in the stack. So currently, we shut down the amount of resource that's available to new SQL requests that come in as far as possible, but we don't turn that into any kind of error or any kind of work rejection at this time.
So in this particular case, if the database was overloaded, if I would try to get more resource to help that new SQL versus actually rejecting it.
I see a new question from.
Yes. Well, I'm just.
Yeah. Sorry, I'm just reading it myself. I hope that's okay.
Well, no, we have to speak the question. So let's
yes.
just clarify that. the so the follow-up question seems to be about how about using a custom designed function to perform consumer group mapping?
And in fact, that's what we do. The basic plot for classifying requests into performance classes is that we look at when the packet arrives off the wire, we look at a set of attributes of the request and use that to classify the particular request, decide which performance class it belongs to. And there are 5 attributes of the request that we look at today. And those are: which service did it come in from? What was the name of the user who owns the session that it came into? What's the name of the program that it came from? And what are the module and action values that have been sent from the mid-tier or from the whatever application is sending the request? Those 5 attributes, you can define groupings of those things. Essentially, any Boolean predicate on those 5 attributes can be used to place a particular request into a particular performance class. Performance classes are then mapped into a specific consumer group. When you're running QoS management and attempting to manage performance classes, we in fact install a specific resource manager plan that has 4 predefined consumer groups. And those consumer groups have fixed numbers of shares, and they're arranged exponentially. So the largest one has 56 shares, and the smallest one has, I don't remember, 3 or 4 shares, a small number. The 4 of them add up to 100 altogether. And we will map a performance class into a particular consumer group to give it more or less access to the CPU. I see there's another.
Yeah, so there's a follow-up question here about the fact that that sometimes module and action are dynamically generated, and therefore how can you accommodate for that? I think it would be appropriate to understand whether that those module and actions are generated in the database code or whether they are coming from the middle tier. Can you address?
Yes. We only look at, we take a snapshot of the module and action that are sent by the mid-tier, okay? And we expect there to be the set of values that might arrive in the module field or the action field are known to the administrator. So the set of values for module, for example, suppose you wanted to drive off module. In the definition of the performance class, you say something like, any request that arrives with a module in this set of values belongs in this performance class. So, and then there's a bucket where things that don't match any of the classification rules get put. So what you're basically saying is, as long as I know a predefined set of attributes, that I can include that list in my classifier. Yes. Basically, today we provide you can essentially specify a table. We don't have regular expression matches at this, or wildcards at this time. We have inset, meaning here's a list of things that if this shows up, it goes in this class. And we also have not inset, which means anything except this list goes into this bucket.
So basically, based on this follow-up question where the module or action is coming from a URL endpoint,
yes,
and if the set has to be predefined, it cannot be wildcarded, is what you're saying.
It has to be predefined. It can be, well, because of the not inset facility, you can say anything in this list goes in this bucket, everything else goes in another bucket.
Okay, so I could basically, instead of having it fall through entirely,
yeah.
I could set up exclusionary logic that would, instead of just simply inclusionary logic.
Yes, and follow-up question, can you help me with the table in list? Absolutely.
Yes, so please reach out to me after the session if you have specific technical questions, which we want to drill down on further for in the interest of time here.
Yeah, the first place to look for the in-list facility is to walk through the policy set definition wizard, and I think it's reasonably clear there, but we're absolutely happy to help.
Right, and one can actually define multiple classifiers for a performance class, correct?
Yes, exactly. Each performance class is defined by a list of classifiers. Each classifier will recognize some number of requests. The first classifier that goes off, that's the one that labels a particular request. The facility, it's a quite flexible facility, I think.
I see. Okay. So I think that should have answered the questions. Moving on here, you mentioned about that QoS Management was introduced in the 11 timeframe.
Right.
Are there specific versions of Oracle databases that QoS Management support, and how do we handle compatibility backwards?
Basically, QoS Management is delivered with clusterware, with the grid infrastructure. So, but it's capable of managing all the databases going all the way back to 11.2. So if you have a 12.2 clusterware install with QoS Management, when you enable it, it can manage any databases that run in that cluster back to 11.204. Okay,
so that should give a broad range of support. But what you're saying is that it's okay for me to run newer, like 12.2 or 18.3 clusterware, as long as I can run those databases in my clusterware, QoS Management can support it.
Yes, exactly. I mean, we talk to the first thing we do when we talk to the database is figure out what version it is and what capabilities it has in the QoS Management space. And we manage, at any point in time, we expect to have a mixture of different releases of databases under management simultaneously.
Okay.
So for another question.
Yes. Well, we'll jump into it here. So there's a specific question as to, are there any new features in 18C relative to QoS Management?
I'm not sure I can answer this. I know what we've been working on, but I don't actually know what made the cutoff. Mark, you might know better than I do.
Okay, so because 18 is a patch release, it's really a 12.3 release of actually 12.202 version of the database. There were relatively few new features introduced in the 18.3 release. Specific to QoS Management, we do have some functionality, but unfortunately it did not make the cutoff in time, so that basically there is no additional functionality in 18.3 that wasn't already in 12.2, outside of bug fixes.
Right.
Yeah, I mean, there's obviously been bug fixes, security fixes, things like that go into any release. So you talked about this idea of performance classes and classifiers.
Yeah.
So we probably already addressed this question about how QoS Management actually supports classifying requests and put them into performance classes.
I think so.
Yeah. So moving on, obviously there may be some overhead associated with making use of QoS Management. Can you describe the nature of that overhead?
Yeah, sure. It's very lightweight. QoS in the database sits on, there is a small amount of code that is executed when a request arrives if one of the attributes has changed since the last request. So the 5 attributes I talked about, service module action, program name, and user, they often don't change between requests. If they do, then there's a call out to a small piece of code that runs the classification again, and we've been unable to measure the overhead of that. It's so lightweight. There's also a small amount of memory overhead in the database for keeping the metrics that we measure. And then there's the actual QoS Management, the QoSM server. Wait, how do I, another question. Do you want me to read the question?
Well, let's finish your answer first. Okay.
Okay, yeah, so there is a single Java process that runs anywhere in the cluster that has uses a couple of 100 megabytes of memory, I think, and has a really low CPU impact. And those are the overheads that we measure and pay attention to, and they see.
So basically, it's just sort of tacked on at my connect. The major overhead is simply a small differential tacked on when I connect to the database, and is sort of lost in the noise.
Yeah, I mean, the very first request causes a classification event. There may be others later. They're really tiny in cost.
Okay. All right. So we have a new question here is, and I'm not sure it's actually relevant to QoS Management, but the question is, how do I change service during a session?
It is actually possible. I don't know how. I don't know the machinery, but there is a SQL command that you can use to change the service. The only ones that we pay attention to changing are module and action.
Okay, well, I think that what's important to point out here is I think there's new functionality in the database to actually have a session dynamically change service.
Right.
That was recently introduced, and so the question is, do we detect that session change within our
No, I don't believe we do. I believe we only get a callback if a module and action change, and we expect that program name and user ID and service are static for a particular session.
Yeah, so we should point out here that the services we're talking about here are cluster managed services and not simply services defined by DBMS service package. So these are the services that you would use servctl to create on a RAC database, and not the internal service package that the database offers. But if you are talking about a cluster managed service and this new functionality, follow up with me and we can determine exactly whether or not we detect that because that is just introduced, I believe, in 18.
Right. Yeah, and we did not make
for PDB.
Right.
Yeah. So we might have inherited the support, but we didn't particularly specifically code to it, I guess.
Yeah.
Does QoS management have any impact on an application's availability, since we're appear to be in the connection path?
No, none at all. We're essentially sitting on the side and watching things go past. We're an observer. We're not an active participant in anything that happens in the database layer. I will argue actually that QoS management may have a positive effect on an application's availability from the end user's perspective, because we're trying to maintain reasonable response times. If response times are too long, the application looks unavailable to the end user. So our goal is to improve availability if you define it to include response time.
Sure, and that makes sense. Now, obviously, you mentioned about the QoS management server that is running outside the database. What happens should that fail?
So it has no effect on anything that the database is doing. It's managed as a clusterware resource. So clusterware will restart the QoS management server, and perhaps on the same machine, perhaps on a different machine if the machine it was running on failed. And at that point, when the server comes up, it says, oh, I'm supposed to be enabled. Here are all the databases I'm supposed to be managing. There was an overhead that I omitted. We actually make a connection from the QoS management server to each database instance. So after a failure will come up, we'll connect to all of the database instances. We'll start gathering data again, and we'll look to see if there's a problem and make recommendations. So there is a failover scenario, but while all of that's happening, all of the databases are continuing to do what they do with no interference or change from the QoS side of the puzzle.
Okay. Going back to the workloads for a moment, are there any limitations on the type of applications or workloads that QoS management can measure or monitor?
We focused on what I would call short-running requests. So we're not aiming at helping to measure and monitor, at least not today, to measure and monitor things where individual requests run for hours. When response times grow to be more than a second or two, the measurement infrastructure that we sit on starts to be a bit less accurate than it is for the shorter operations. So our sweet spot is actually anything that where response times are under a couple of seconds, which is a lot of the load. The other place where we can notice problems but not actually make good recommendations about them are situations where response time is made up in large measure by time spent in parallel query slaves. We measure that, we notice the problem, but the knobs that we have today don't work effectively for managing how much time is spent in the query slaves. So those are the two things that I'd say, measurement, monitoring is fine, but less accuracy for really long-running things, and we won't be able to make good recommendations about things that run parallel query as a large fraction of their response time.
So from a standpoint, can you clarify the distinction between what we can QoS can accurately measure and monitor versus what it can actually manage?
Oh, so we can measure and monitor any workload. No problems there. It's managing them in those two categories that that I mentioned a moment ago. It's the management side that doesn't work so well for really long-running things. I mean, for really long-running things, you probably want something more like, you know, when is this job going to finish? And that's not a facility that we're trying to provide today.
Okay, that sounds good. So do we have any other questions? We're at the top of the hour. Do we have any other questions from the people from chat? Okay, so it looks like we don't have anything in the queue. So I want to thank everybody for attending. We're at the top of the hour here. And I want to announce that we're going to continue on with the AHF series next month in September, bringing in information about Oracle Database Hang Manager, which is another autonomous action that is taken on behalf of maintaining database availability. So please tune in for that next month on September 25th. And I want to thank you, Barry, and thank everybody who's joined, and you will have access to this recording up on YouTube in the next few days. So everyone, have a good day.
Thanks, everyone.